Hi, I'm Dan, and this is part of a series of videos about the future value of money. So, how many years would it take for $8,000 to grow to $24,000 when deposited into an account that has 9% annual interest and is compounded monthly? Well, as we went through in the last video, the future value of money equals the principal, which is the amount that's originally invested, times, in parentheses, 1 plus R, which is the nominal interest rate, expressed as the decimal, divided by N, which is the number of times per year the interest is compounded, close parentheses, to the exponent to the power of the number of times the interest is compounded per year times the number of years that the investment lasts. So we would, for future value, we would enter 24,000 and equals, for principal is 8,000 times, then in open parentheses 1 plus the rate of the interest rate is 9%, so we write that in nominal form, so it would be written as a decimal as 0.09 divided by 12 for N, because that's the number of times per year the interest compounds, once a month. There are 12 months in a year. Then close parentheses, then to the power of 12, which is again the number of times that the interest is compounded per year, times T, and that's T is how many years is it that's going to take to go from 8,000 to 24,000 at 9% compounded monthly. 0.09 divided by 12 equals 0.0075. Then you add the 1 to that, and then you divide each side by 8,000, and you've got 3 equals 1.0075 to 12t. This is where we introduce the log function, as the unknown t is located in the exponent of a number. Since the log function is the inverse of an exponential function, using the log function will allow the exponent to be pulled down to the same line as the rest of the numbers. And once that is done, we can use regular algebra, such as division, multiplication, addition, and subtraction, to solve the equation. When solving an equation, the log can be applied to both sides of the equation when both sides are positive and there is an unknown in an exponent. Now, using the power rule that applies to all natural logs, the power rule states that the natural log of a to the k, in which case a would be 1.0075 and k would be 12t, would equal k, which again is 12t, times the log of a. So the natural log of 1.0075 to the 12t equals, through the power rule, 12t times the natural log of 1.0075. E is a mathematical constant that's used to solve problems involving growth and decay. E is approximately 2.718. E can be thought of in the same way that pi is a mathematical constant of approximately 3.14 that's used to solve problems involving circles. What does it mean to take the log of x? What is actually taking the log of something? Well, it is, what does the power of e have to be for it to equal x? So what does the power of 2.718 have to be the power of whatever number you're looking for? So in this case, on this side of the equation, the natural log of 3, what does e have to be the power of to be 3? And using a calculator, it was determined to be 1.098 and some change. On the other side of the equation, you have 12t times the natural log of 1.0075. So what does e have to be in order to be 1.0075? Using a calculator, we determined that to be 0.0074 and some change. So now you can use straight algebra with this. Remember, this is 12t times 0.007. So we could just times the 12 with the 0.007 to get 0.007 1.089 and some change, t. And then we have, this is still the natural log of 3, which is 1.09. And we just divide each side by 0.089. And t turns out to be 12.25252, which is our answer in a decimal format. However, we speak in terms of months. So what does 0.25 times 12 equal? It equals a little over 3, so the final answer is 12 years, 3 months. So it would take 12 years and 3 months to turn $8,000 into $24,000 at a 9% annual interest rate that compounds once a month. Okay, now let's check our work. In order to check the work, basically, we're going to plug in 12.252 into the future value equation where t is, because that's the answer we got, and that's the answer we're checking. And everything else stays the same, except the future value, which we know is 24,000. We're just going to leave that as the unknown and solve the equation. And so then as you go down, 0.09 divided by 12, again, we got these, this is basically the same exact work we got before. The only thing is that it's 12 times 12.252, because it's going to be n times t, is 147.03. So what you've got down here, you work this out, and you've got 8,000 times 1.0075 to the power of 147.03, which equals 8,000 times 3. The future value is 24,000, which matches what it should be. So therefore, the answer was correct.